afternoon, ladies and gentlemen. My name is Francis, and you are welcome to my YouTube channel. Please know that if you have not subscribed to my YouTube channel, click the link below and subscribe, like my page, and share. Today, I will be discussing reflection of light through plane mirrors. I discussed about it yesterday, but I wasn't able to complete it. So today, I will be completing the aspect of reflection of light through plane mirrors. First of all, I want you to understand what reflection really means. Reflection of light is the process by which an incident ray is sent to a plane mirror and is reflected towards another angle. So what we are going to do today is to calculate the angle of incidence and also to calculate the angle of reflected ray. So I would like to state the law of reflection. The first law of reflection states the angle of the incident, the reflected, and the normal all lie in the same plane. And also, the refractive index is equal to the sine of the incident angle all over the sine of the reflected angle. So this simple illustration here shows what we are going to do practically. So what you do is measure a line 10 centimeters such that AB is equal to 10 centimeters. So once you draw a straight line, AB 10 centimeters, you will measure 5 centimeters, which is the midpoint of the line AB. So from A to B to this point is 5 centimeters. You draw a perpendicular line which is representing the normal to the plane. So you draw a perpendicular line. After drawing a perpendicular line, we are going to see the changes in the reflected angle and also the incident angle. So what you do is also draw a perpendicular line at the end point A and also a perpendicular line at the end point B. So we are going to take we are going to measure 5 centimeters downwards. Then at the point A, measure 1 centimeters. So once you measure 1 centimeters downward, you mark the point and you join the point to the normal. With a straight line, join this point 1 centimeters to the normal. Then after joining it 1 centimeters to the normal, what you do is you replace your plane mirror here, which is 10 cm. Then you would see the reflected ray through the side of the mirror. So once you see the reflected ray through the side of the mirror, you insert 2 pins at the incident ray here, and we are going to block the rays of the pins at this point such that they are in straight line, because the principle of light says that they travel in a straight line. So we are going to block these 2 points too. We are going to do that practically now. Pause. Alright, you can see our illustration here. We have our plane mirror, we have the drawing board, we have our drawing paper fixed firmly with the help of thumb pins on the drawing board. So we are going to see, I have fixed 2 pins at the point from here to here, which is 1 centimeters. I fixed 2 pins, so I'm going to block the reflected ray at this point, which I have done. I will now remove the plane mirror and measure the angle . So in measuring the angle, it was found out from what I'm reading here is the incident angle is 79 degrees. Yes. Why the reflected angle is 74 degrees. This is the table of our results. Here is showing the 1 centimeter, 2 centimeter, 3 centimeter, 4 centimeter, 5 centimeter. Then x inverse is showing the inverse of x. Inverse of 1 is 1, inverse of 2 is 0.5, inverse of 3 is 0.33, inverse of 4 is 0.25, inverse of 5 is 0.2 0. And the incident ray from the practical that we did was gotten to, the incident ray is 79, the reflected ray is 74. Of course, you know, under normal ideal conditions, the incident ray should be equal to the reflected ray. But since it's a practical, we are going to get the value of theta by dividing 79 by 74. So we have 79 and 74, we divided by 2, we have 79 and 74 divided by 2, we'll have 76.5. And 68 plus 66 divided by 2, we'll have 67. 59 plus 56 divided by 2, 57.5. 50 plus 50 plus 3 divided by 2, we'll have 51.5. 46 plus 49 divided by 2, we'll have 47.5. Then we are going to get the values of tan theta. Tan theta now will be tan 76.5, which will give us 4.17. Tan 67 will give us 2.36. Tan 57.5 will give us 1.57. Tan 51.5 will give us 1.23. And tan 47.5 will give us 1.09. So what we will do is we are going to plot a graph of x inverse against tan theta, determine the slope of the graph. Pause. From here, this is just the illustration of the graph. This is our x inverse, the values of our x inverse against tan theta. So we'll find out that using a scale of 0.2 cm, using a scale of 2 cm to represent 0.2 units on the vertical axis, and a scale of 2 cm to represent 1 unit on the horizontal axis. Plotting our graph, of course, this is just an illustration. So in order for us to determine our slope of the graph, slope of the graph is equal to change in x inverse all over change in tan theta. Then from our calculations, we have 0.5 minus 0.2 over 2.36 minus 1.09. We are having our slope to be 0.24. So we have come to the end of this illustration of reflection of light through plane mirrors. Please like my YouTube channel, subscribe, share my videos, as I will be posting subsequent problems and solutions towards our Neco exams 2021. Make sure you try to answer also the questions that are related to light, because they might ask you what are the reflection, what is the laws of reflection. You can actually state that. Thank you and God bless you.